Don't forget, right now, Jam and I are running a special campaign at our Ko-Fi. If you go to ko-fi.com/chem4yourlife and subscribe at any amount, Jam and I will send you a special Chemistry for Your Life sticker. That's ko-fi.com/chem4yourlife to learn more about why we're doing this and how to subscribe. And now, on to today's show. Hey, I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life,
The podcast that helps you understand the chemistry of your everyday life.
Okay, Jam, this week we're going to be responding to a listener question.
Okay.
That I think is really cool, and I learned something new, so that's exciting.
Nice.
So listener Shane W. responded to our story, and he has an Instagram called Crafts and Conservation where he makes really beautiful woodworking pieces.
Oh, nice.
So that will make this next question make a little more sense, I think.
Okay.
But he asked, why does iron turn wood black?
Huh. I guess I didn't even know that it did. I don't know much about that whole world.
Me either. So go right now, you, Jam, and listeners as well, and look up, if you're not driving, like if you can safely do this, go look up ebonized wood.
Okay, I'm on images, and it looks, I guess what I expected from the phrase ebonized wood, it looks black. Mm-hmm. But you can see the wood grain still. So there's like some shelves and some boards and stuff like that. And you can, at an angle, you can still see that it has the grain. So it's not like it's just, it doesn't look like it's just been painted that way or whatever. I don't know.
Right. It's like stained that way.
Yeah. Yeah. Basically like a super dark stain is what it looks like.
Right. Absolutely. So that's kind of what it is.
Okay.
So what happens is, surprise, surprise, a little chemistry reaction.
Huh. And those are rare. I mean, chemistry doesn't happen very often almost anywhere.
Nope. Chemistry is barely part of your everyday life.
Interesting.
It's very exciting. It's also kind of hard to find resources on this. So I did the best I could with what I had.
Okay.
But you'll find out at the end, there are a lot of other sort of related things. So it was hard to narrow down on this specific thing.
Okay.
And the field we're going into right now is inorganic chemistry.
Okay.
So that's not organic chemistry. It's inorganic, non-organic, inorganic chemistry.
Okay.
It's hard to say that when you often say inorganic chemistry, like, oh, I was in my organic chemistry class the other day. And so it's sometimes hard to tell the difference between them.
Totally. That's one of those weird things where it's like, man, what if we could have changed these words a little bit before we really got going as a society?
So inorganic chemistry deals with things other than carbon, like metal, usually. It's metal bonds, metal things are inorganic chemistry. And we've talked about some inorganic chemistry stuff before. We talked a lot about actually inorganic type things on our episode about rust, and that's going to come up a lot today as well.
Okay, got it. So doesn't have anything to do with it being like, free range, non-GMO chemistry.
No, nothing like that.
Just doesn't have anything to do with carbon.
Yeah, there are carbons involved, but the main chemistry is happening on the metal.
Got it. Okay, got it.
Okay, so what happens when you put iron? It's actually iron ions. So iron that has lost some electrons.
Okay.
On wood. It's reacting with something in the wood called tannins to make a new thing. And that new thing is black.
Okay.
So that's a lot like with rust. The iron was reacting with the oxygen.
Mm-hmm.
And it created a new thing that was red.
Oh, right. Yeah.
So that's exactly what's happening here, is there's something in the wood called tannins, and those are reacting with the iron ions that we're going to put on it. and it makes a new thing called iron tannate, and that's a bluish black color. And that's why, in the simplest terms, why iron turns wood black.
Okay. Huh.
Doesn't really turn the wood black as much as it creates a new substance that's black.
Yeah. Interesting.
Okay, so now let's dig into those deets.
Okay, sweet.
Okay, so what is a tannin? I'm sure everyone's wondering that. Have you heard the word tannin before?
I have heard the word before. I can't remember if it was related to this podcast or if it's been part of any of the like hobby dives I've done on the internet about. I can't remember if that's part of leather stuff at all and how they color leather and stuff like that.
It is.
Okay. So it sounded familiar.
Yeah, so we'll probably talk about that a little more at the end, but I thought you maybe had heard the word tannin because you do like leather quite a bit.
Yes, I do. In like a normal way, everyone. It's just I like things to be high quality and last a long time.
Right. Yeah. So there's not a clear definition when people say tannins. They just generally refer to a class of molecules found in nature. And when I say class of molecules, we've talked about that before. A class is just like a group that people put together that are similar to each other.
Based on how much money they earn, right?
Based on, their status and the socioeconomics. No. It's more like they're similar properties, put them together. Like a school of fish is similar fish or whatever.
Okay.
Or maybe a school of fish is the same fish, and that was a bad example.
Right. Good point.
Yeah, maybe it's like if you have a family of colors, they're all different types of red, but they're all reds.
Yes.
It's kind of like that. They're similar in that they all have these specific properties, but they're not the same ones.
Yes. Okay. That's helpful. That color one helped me.
So the tannins are in a class of molecules that are found really commonly in nature and plants and stuff. And they have polyphenols. And that just means they have a lot of stable rings called aromatic rings with alcohol groups on them. There's a lot of those.
And that word came up recently. And I feel like within the past 12 episodes, some point you said that word.
Polyphenols or phenols?
Polyphenols.
I believe it, but I don't remember about what.
Yeah. Man, there's no way of knowing. Boy, there was some recording of all of our conversations, but there's not.
I wonder if it was in the syrup episode.
Oh, maybe. Anyway, we retain information, everyone. We remember exactly what things we talked about week to week.
I think you're right. I think that sounds right.
I think what's funny is that I definitely heard you say it, but I don't remember what it was. It might have been that you just said it's one of the many things that's created as a byproduct whenever syrup is boiled down.
Oh, but maybe so. Yeah. That sounds right. That would be my guess about what we've talked about lately.
Yeah. But who knows? If you know.
Knows? Who knows? Past us knows on whichever episode that was. So tannins are just that class of molecules.
Okay.
But tannic acid is a specific structure. It has a glucose, which is a type of sugar ring in the middle. So it's got a big ring made of carbons and oxygens in the middle, and it has a bunch of those phenols around it.
Okay.
It's got like 5 of them, and then each of those have another one on it. So it's 10 total all around it.
Okay.
And that tannic acid will find the iron ions and bind to it.
Okay.
Usually 3 tannic acids bind around the iron.
Okay. And just to make sure that, obviously we had a couple of little tangents and rabbit trails. This is, we're talking about the tannins are part of the wood already?
Yes.
Okay. I just wanted to make sure that I knew which thing was part of what already. So that's already there.
Yes.
And iron has not, even before iron's been introduced or anything like that.
Yes.
Got it. Okay. Cool.
And I wasn't super clear on tannic acid, if that was one of the tannins that was already there, or if when you expose it to acidic conditions, a tannin like converts to tannic acid. My guess is that tannic acid is one of the tannins already in wood.
Okay, got it.
But it was hard to find resources specifically on this exact reaction.
Mm-hmm.
There was a lot of resources about what happens after, you know, about this thing that's formed, but not a lot about how it is formed in this process.
Mm-hmm. Mm-hmm.
But if anyone else can find anything, I'd love to hear about it. So if you're an inorganic chemist and you do all kinds of ebonizing wood, hit me up. We want to hear from you. So this tannic acid, 3 tannic acids will form around the 1 iron ion. And this whole structure with the 3 tannic acids bound to the iron ion is known as a complex.
Okay.
Which is fun because it's kind of complex. It's a metal complex. Okay. So a metal atom with molecules around it, or sometimes atoms or other ions, is known as a complex.
Okay.
The molecules that are around the ion, in fancy inorganic chemistry terms, are called ligands.
Okay.
I just felt like I'd share that with you guys. In case you're chatting with an inorganic chemist, you can say, the ligands form a complex with the whatever, and then you'll sound fancy.
Also, ligands, you said?
Ligands, yes.
Interesting. This sounds kind of fun to say. I feel like I would also like to try to find an excuse to say that word.
Yeah, it's fun. The ligands form a complex. I don't know if you'd say with tannic acid, or the tannic acid acts as a ligand to form a complex with the metal or something like that. So you can sound fancy, but really all it means is that tannic acid forms bonds with the iron to make something new.
Okay, got it.
So that's a little quick inorganic chemistry lesson for you. And really what the tannic acid does is give some electrons to the positively charged iron ion so that it's neutral. So it can all neutralize out and be stable and happy.
Got it. Okay. And then they're sharing those electrons, right? Like they don't.
Yes. I think in this kind of bond between the ligand and the metal, they're shared electrons.
Okay.
Sometimes one thing loses electrons, the other thing gains electrons, and they just hang out near each other. But I think this is more similar to sharing the electrons.
Okay. Cool. Because I was wondering.
Don't quote me on it. But that's what my inorganic chemistry textbook said earlier today.
Okay. I was curious, like, why they would stay together if they weren't sharing them, but I guess it sounds like that can happen sometimes.
Yes, sometimes
other scenarios.
That does happen. Like table salt is NaCl, and really it's positively charged sodium and negatively charged chlorine, and so they're not really sharing electrons, but they do hang out near each other because one's positive and one's negative.
Interesting. Okay, so in this case, it seems like they are sharing.
Yes, that's how my textbook made it seem.
Okay.
But I'm not pretending to be an inorganic chemist out here today, so...
And can we even trust books? It's jury's still out.
Yes, we can trust books. Some books, anyway. Okay. So now the question is, how do you get iron ions to just put on your wood?
Okay.
And the way that you get it is exactly what we talked about in our rest episode. It's that you can dissolve iron with acid. So you can use vinegar and put something like steel wool in there that's pretty thin so it'll dissolve more easily. Leave it in there for a week or so and you'll basically get a solution with dissolved iron ions in it.
Oh, wow. Interesting. I didn't think about this being something that you would make. Like I thought you go to Home Depot and you get, dissolved iron, but I didn't even think about that you could maybe do it yourself.
So you get your wool and you add it to acid or add acid to it. It's going to react and the iron ions will interact with the negatively charged part of the acid and the positively charged part will interact with oxygen or something else. I didn't look up the specific reaction before we started. But if I had to guess, and based on memory from the rest episode, I would guess that it makes some kind of iron salt. So the iron's a positive charge, and maybe what used to be part of the acid would be the negative part.
Okay.
And so then you have an iron salt just dissolved in your acid, would be my guess.
Okay.
And the acid that I believe is most commonly used for that is just vinegar.
Wow. That's the one that we all have, basically.
Yeah. So you can do 2 reactions, one to get free floating iron ions, and then put it onto your wood that has tannic acid in it that's going to react with those ions. So you're doing another reaction to make iron tannate, your lovely blue blackish stain.
Wow. Interesting. So as it's dissolving, even just the iron from like the steel wool or whatever, it will start turning the vinegar black already?
The vinegar already is, even though that's not iron tannate, it does get kind of dark in the vinegar solution, which I'm not sure if it's because whatever is dissolved in there has kind of that color.
Oh, okay.
But when you put it on the wood, it looks a little dark, but as the reaction happens over time, it gets darker and darker.
Wow. Okay.
Until it's reached its like dark stain color. And
yeah,
it varies depending on the tannins that are in the wood. So if there's more tannins in the wood or less tannins in the wood, it'll go darker or lighter. Because there's just either more or less of the substance. So it can look more gray.
Okay.
And if there's a different type of tannins, I believe one paper referred to them as condensed tannins, it could make a greenish black instead of the bluish black, that you can see there's sometimes like an undertone to black. So it can make bluish black or greenish black.
Got it. Okay. Interesting.
Okay. Are you tracking?
I think so, yeah.
All right. Do you want to explain that back to me? And then I'll give you a whole host of fun facts about tannins.
Yes, I'd love to. Okay, so you know how sometimes we've talked about molecules interacting and the reasons why they do, almost like a group of friends?
Yes.
Okay, so in this case, it kind of seems to me like you've got the iron ion who is lacking electrons, right?
Yes.
So basically, if he's he's a friend out there, he basically has less of, say, what everybody wants when you're a teenager, like snacks or something.
All right, less snacks. Yeah, that's a good one.
Missing out on that. But then these tannins, this tannic acid, all of them have a little bit more than they need. And so this kind of mooch guy shows up, the iron ion, and he's like, these guys over here, they seem like they've got plenty. And so he just kind of sneaks over there, and it actually works out fine because they are happy about it too, because they have more snacks than they could even handle.
Yeah. So they don't have to carry around these extra snacks.
Totally. They're like, okay, I guess, yeah, we'll let him in our group. And so, so then they end up having a nice sort of happy scenario where he's in the middle, being able to have access to all the snacks. Gosh, dang it. This is so dumb. No,
it's not.
And then,
it's good.
And then, and they're happy too, and they stick together, basically.
That is exactly right. I think so. I think that was a great analogy for it.
But so that's like obviously how we get that complex that ends up looking black, right?
Yes.
So before that, even we had to get the iron dissolved into a way to apply it to the wood, which you said you do with a acid. And so we just have to have some version of iron to dissolve into it, like steel wool or something.
Yeah.
And so
it's basically like you're doing 2 chemistry reactions this time.
Right. Because I guess it wouldn't work very well just to like lay some steel wool on top of a piece of wood and call it a day.
No, because the ions I don't think would be very available at that point.
Yeah. So you do that, and then you have a solution of the iron ions in something that can then be applied to the wood and then can have a chance to interact with the tannic acid in there to buddy up, share snacks, and turn black.
That's exactly right.
And did you say if there's a reason that it turns black specifically?
I don't really. So why things are colors is pretty much usually just about the alternating double bonds and the light that they absorb.
Mm-hmm.
And so that would be my guess is there's a lot of alternating double bonds in the tannic acid. And so to put all those together and then to have 3 of them, that seems like a lot.
Yeah.
So that would be my guess, but I don't know for a fact.
Interesting.
Okay, that was great. I think you did a really good job.
Dude, thanks. That's also one of the things where I feel like I just don't know much about that whole world at all, but this is very interesting. I'm sure there's probably tons of chemistry in all the types of staining of wood or whatever, which I'm sure is
definitely.
Cool.
Well, here's some other ways tannic acid is used or tannins are used. 1, tannins are present in wine.
Okay.
2, it seemed like they were looking into this iron tannate complex as a way to clean wastewater.
Okay.
3, it may, if your food has a lot of tannins in it from tea that you're drinking or stuff that's made from plants, which is where tannins are naturally found, it could inhibit your iron absorption in your digestive system.
Oh, because they buddy up with the iron instead of it getting into your system.
Mm-hmm.
Oh, interesting. Huh.
And you already hit on this. Tannins are used in tanning leather.
Nice. Dude.
And I don't know, but I'm wondering if that's where the name came from.
I would not be surprised. That would make a lot more sense because it's not like the whole point has always been to make leather a tan color. Mm-hmm. That's certainly ends up being what I think us lay people think is like, oh, you're tanning it. You're making it
turning it tan. Yeah.
But I feel like that certainly was not always what they were going for. So it seems like that chemical could make more sense as the name.
And then finally, well, there's 2 more that are pretty cool, I think. Iron tannate can be used as a rust converter. So if you have something that you want to restore that has a lot of rust on it, you can use tannins or tannic acid to convert the rust into, it'll be like a blue-black cover. So they'll have rust converters that both have tannic acid and a polymer, so it converts it and then sets a coating over it all at once.
Wow.
And iron tannate was used to dye clothings and garbs long before modern times.
Dang. Before I probably even knew what was happening, but it was just like, hey, this stuff can do this.
This stuff does this, so let's make it work.
Yeah.
Isn't that crazy?
Yeah, that's crazy. Dude, and there's like so many questions surrounding the leather stuff that I feel like I have for you at some point. But there are like many types of tanning of leather too that I've always wondered about. So maybe someday we can purchase that as well.
Do something on that. And I think in wine, that could also be interesting. I think tannins are going to come back up. Let's just say that.
We haven't seen the last of them.
Haven't seen the last of them. And I know my brother and I have talked about them, and my sister has talked about them. So I know we're going to talk about tannins some more. So it's just a matter of time.
Okay. Sounds good.
All right. Well, do you want to share about something from your week this week, Jam?
Yes. So kind of on the theme that we've been talking about of being excited that some pandemic stuff is getting a little more hopeful and more people getting vaccinated. So it's feeling a little safer to hang out with people sometimes. And that's been nice, including getting the opportunity to hang out with some friends of ours who also had a baby during the pandemic. And so then our son and their daughter were able to hang out and like interact with each other, and which they haven't really done. They haven't been around other babies, which is kind of crazy. And so it was a lot of fun and just cool to watch them interact and like touch each other and stuff, and then like play with toys on the floor together and stuff.
Oh,
and
I love that.
We also definitely secretly hope that they will end up, falling in love someday. But we're just trying to put them near each other and just let them have that idea at some point in the future.
But also just remember, if it's either of you guys and you're listening to this in several years in the future, love is not the ultimate goal in life.
That's
Romantic
true.
love is not the ultimate goal in life.
Yeah, it's sort of selfish because we want a reason to be sort of related to our friends. So I'll be honest about that being a huge part of it. So.
Well, mine is not as cute as that.
Okay. Well, that's okay. It'd be hard to have a cuter one. So
it would be. So what I've been trying to do is slowly convert my lifestyle to be less and less waste. And I feel like I keep finding little plastic tricks, such as bounce sheets. That was my last one.
Oh, yeah.
And I realized while I was shaving my legs in the shower that also my razor has plastic. And it's been subpar lately, it gives those like bumps because my skin's sensitive or whatever. So I went in search and found a safety razor.
Oh, nice. Yeah, those are classic.
And they don't produce waste because you can recycle. You have to do it a specific way, but you can recycle the blades. And so I found it's rose gold and silver, and it's beautiful. And I did all kinds of research, and I picked out one, and it came in the mail, and it's really beautiful. And I'm so excited to use it. And I'm going to use it with a soap bar that we got as a gift from some listeners.
Oh, yeah. Nice. Very cool.
So we got a cool gift in the mail from some listeners. It was Isabel and Michael, and they have a little shop online. I think it's called Jolie Isabel or Jolly Isabel. It looks French to me. And it's really cute. And they also sent us some lotion, and it smells amazing. And a bath bomb. I'm so excited. So I'm really excited for that, and to use my new soap bar with my new shave setup so that I can be nicer to the environment.
Dude, nice. Before I even thought about the environmental side, whenever I was actually shaving with the razor, I had done a lot of looking into safety razors, and that is very cool. I've also, they're really cool, and I wanted to learn how to use one. But then I got so lazy that I was like, I'm not even going to use a razor. I'll just use an electric trimmer thing and not ever be fully clean shaven. And that has also been pretty good for the environment too. So.
Yes, that was an option online for that. When I was looking into it, was using an electric razor. But I like this shave. I want a close shave, so
yeah.
I'm looking forward to trying it out. I'll let you guys know, but it's one more area where there's no plastic in my life.
Nice.
And that was inspired by my friend Natalie, who also invested in a nice safety razor. So.
Nice. Very cool.
So thanks, Natalie, for inspiring me to be more friendly to the environment. And thanks, Jim, for coming and learning about how to use iron to turn wood black. And thanks all you listeners as well. We couldn't do this without you, and we're so thankful for you.
Well, Melissa, thanks for teaching us. And thank you, Shane, for sending in this idea, this question. Melissa and I have a lot of our own ideas for topics of chemistry in everyday life, but we want to hear from you. The things that you wonder about, things that maybe even in your work, things that you work with, like Shane does with wood. Ask us. We'd love to delve into that with you guys. So reach out to us on Facebook, Instagram, Twitter, and Gmail at Chem for Your Life. That's Chem, F-O-R, Your Life, to share your thoughts and ideas. If you'd like to help us keep our show going and contribute to cover the costs of making it, go to ko-fi.com/chemforyourlife and donate the cost of a cup of coffee. And between now and the end of May, if you become a monthly subscriber, Melissa and I will send you a note and a sticker as a thank you. But if you're not able to donate, you can still help us by subscribing on your favorite podcast app and rating and writing a review on Apple Podcasts. that also helps us to share chemistry with even more people.
This episode of Chemistry for Your Life was created by Melissa Collini and Jerem Robinson. References for this episode can be found in our show notes or on our website. Jerem Robinson is our producer, and we'd like to give a special thanks to A. Hefner and A. Collini, who reviewed this episode.